Hi, everybody. Today I want to talk to you about performance tuning your Puppet infrastructure, except that creating a talk, as you know, is a little bit of a journey. And I realize that that's too narrowly defining what we're talking about today. So I think a more accurate title would be to say just owning your Puppet infrastructure. Is what I really want to express today is an idea that a lot of people put an arbitrary division between their infrastructure that they rely on, like Puppet, and the applications that their business is using Puppet and their other infrastructure to run. And it's an unnecessary distinction. If you think about what Puppet is, especially a modern Puppet system, you've got the Puppet Master, which is a Ruby application. You have a Puppet DB, it's on the JVM. You have databases. You have asynchronous message queues. All of these things that we attribute to any modern complex web application. And so what I'd like to talk about today is how to think about your infrastructure, and in today's example, we're going to talk about Puppet, as an application itself, and how to apply the same types of both performance monitoring concepts, but also just application management concepts. So I work at New Relic. For those of you who are not familiar with New Relic is a software as a service software analytics company. We have little agents, we call them, that go out and they run in people's applications and they report back telemetry data to us on performance, on business analytics, on all kinds of different things. So all of those agents out there in the field come back and connect to our data center where we store the data, where we run our applications for people to view the data. It works out to be about 200,000 HTTP posts every second. We have an environment, it's roughly 300 machines, and we use Puppet to keep that in check. And these numbers are big, but they're not huge by today's standards. And like many companies, we were smaller in the past. 4 years ago when I started, and when we first put Puppet in place, we had 12 machines. And so we've had kind of the traditional journey as we went from an environment that Nic Benders put together like in an afternoon on Puppet to something that's capable of running hundreds of machines under high load. And along the way, we ran into a lot of the pitfalls that those of you who've been working with Puppet for a while may remember from the bad old days around performance. Honestly, we were initially just baffled. We would look at stuff and say, well, I don't know, it's like the Puppet Master isn't completing its catalogs, ops sucks. And we finally realized that our own applications don't get that kind of treatment. When the UI for New Relic's web tools is slow, we don't say, oh, New Relic, we instrument it, we improve it, we attack that problem. And then we could attack Puppet the same way. So there's going to be a lot of hands-on examples throughout this, because I really want everybody to be able to leave after the talk today and have everything they need in their mind to go back and implement the kinds of things that I'm talking about. So to save you furious scribbling or typing of notes, everything up here has already been posted online. You can go to that URL, all the slides are there, and more importantly, the config files and things like that have been broken out of the slides so you're not trying to cut and paste out a keynote. So what do we do when we manage our applications? So, well, we use source control so that people can collaborate. We have continuous deployment so that we get the value that we're working on out to our customers as quickly as possible. We do performance monitoring to see how our application's running and to what parts of it are fast and what parts are slow. We do an operational analytics so that we can go back over our data and slice it apart and find the pieces that we're interested in and ask questions of the data we're collecting. And we do log collection, so we have a historical record of what has occurred. So these are how we do this at New Relic. Every company is different. I'm sure your company has a slightly different set of these, but these are relatively normal. For our source control, we do GitHub. We run GitHub Enterprise, and we rely very heavily on the pull request model. For continuous deployment, we have Jenkins, which runs Capistrano jobs. It's very, very straightforward. I heard somebody say there was a drinking game where you had to drink every time we mentioned Jenkins. So those of you who are following along, I hope you're well equipped. For performance monitoring, of course, we use New Relic. You know, we get it for free. We're at New Relic. We really like the product. And the same for operational analytics. And for log collection, it's Heka, which takes log stash formatted messages, puts them into Elasticsearch, and then Kibana on the front end. So how do we manage our infrastructure, and how do we manage Puppet now? The same stuff. You know, if we think about this, all of those tools that are applicable for running the New Relic application are also applicable for running Puppet. Back when I set up our first Puppet environment, we had source control theoretically. We had a Git repo that we put our changes in, and so it gave us a history. But you know, now we have GitHub, we have pull requests, we have the same deployment, the same monitoring. You know, it's just use the same tools that you use in the rest of your business, whatever those tools are. So I started into this topic already. It's this idea that the start of any application management is to control the source code. I'm assuming that every single person in this room already has their Puppet config into some kind of source control system. Just saying, be sure you're leveraging it. We weren't. We had our code in source control, but we weren't taking advantage of it. If we think about the differences between our original system, where it was just a record of changes, versus the way our applications are run, and it really jumped out at us. The way our applications are handled is kind of, we think of it as a internally open model, where each team is the maintainer of their own systems, but everyone else in the company are contributors. And so if you want to make a change to the UI, but you're not on the UI team, you can fork it, you can make your change, and you submit a pull request. Boom. Fork it, make a change, pull request. This is a great workflow for Puppet. All of our dev teams now are submitting pull requests to us when they want changes made inside the infrastructure. So we gave people the ability to test Puppet locally using Vagrant. We gave them the tools via pull requests to come in and say, hey, I want to make this small change to something that Puppet's managed. And then the site engineering team who own the Puppet system act as the maintainers of the code base. And so they review the pull requests, they go back and forth and work with people to get them correct, and then they merge them. Once your code is merged, of course, it's not doing you any good until it's running. So again, continuous deployment. As I said, we use Jenkins and Capistrano. It's an extremely simple system. We lifted the system we use for our Puppet code deploys directly from our the RPM UI, the primary New Relic application. The way it works is GitHub puts something in SQS that says, hey, there's been a change to this branch. Jenkins picks it up off of SQS, runs a shell script that runs Capistrano, and the code gets deployed. Previously, we had a pretty elaborate system involving Puppet sync and just all these various ways that the Puppet master was pulling updates to itself. But the problem with this is that it didn't give us a kind of the chain of control. It didn't interact with our other tools. It just wasn't a part of our main system. So by moving to the same deployment system that we use for our internal websites and our public websites, now all of a sudden the Puppet code base is a member in good standing along with the rest of our apps, and we can do things like hook it up into HipChat, and so we have a HipChat room that shows when activity happens on the Puppet code base, when it gets deployed. If you make a change to master, it's automatically deployed to our staging environment. The staging, we have a complete separate staging environment for Puppet, just like you would for any other application. When they look good, we merge into production, and then it goes to production. It's the same tools, and we've had a tremendous value. I would say of all of the things that I'm going to talk about today, this seemingly simple change of moving our Puppet code base to use the same continuous deployment system as our application is the one that we've had the most benefit from. After source control and deployment, the next big piece for us was to do the performance monitoring. As I said, luckily, New Relic is a performance monitoring company. We have this great software that we put in place in applications to report metrics, and it works great in Puppet. So it was the obvious choice for us. There's a quick warning slide here. Do not fret when you see pages of text. Once again, this is all put up somewhere else, and it's probably wrong for your environment anyway. These examples are what worked for our Puppet Enterprise 3.1 system. What's going to work for you is going to be a little bit different, but there's not a lot of code here. This whole process of instrumenting this application took maybe 2 hours end to end. It's almost as, could be done in the amount of time it's going to take me to tell you about it. So don't be afraid of it. It's very easy. If you don't have a New Relic account yet, you just sign up online, get a light account, and the metrics will report into it just fine. So starting off here, the Puppet Master, we can take the New Relic RPM Ruby gem and just drop it into our Puppet Master, which, as I said, is a Ruby app. It's a rack app in specific, which is a common HTTP framework. The New Relic RPM gem already knows how to instrument rack apps, so no additional configuration is required to get it off the ground. For Puppet Enterprise, be sure when you install the gem that you're using the Ruby that comes with your Puppet Enterprise and not your system Ruby, because you have to make it as the private version of Ruby for Puppet Enterprise. And then the control point here is a little bit weird. What I found is that the best way to instrument the Puppet Master was to just edit the config.ru file directly. There's some smoother ways that this could be done, but this is a really simple mechanism for making it happen. And so it's working well for us. If you want to do something fancier, let me know, and we'll I'll add it into my notes. The file on the bottom is the New Relic YAML file. This is just a basic configuration that's required for every New Relic agent. Needs some basic pieces of information. It needs a license key, needs to know what application name to list it as, and the log file path I've set here to be the same path as the Puppet logs normally go to. So you put this in place, you restart your Puppet Master, and you're going to see something like this. And so this is showing just your basic application performance for the Puppet Master application. The large blue mountain range there is Ruby time. The green is web external time. Web externals, in the case of Puppet Master, for us at least, is primarily PuppetDB, because the Puppet Master is talking to the PuppetDB using the net HTTP library, and so it's instrumented automatically. If you're still awake, you'll notice that the transactions list is pretty boring, though. It just lists everything lumped into a single transaction, which just says, hey, it's all in rack call. This is not very useful. So what we have to do is to go back in and force the Ruby agent along a little bit. The Ruby agent comes with built-in framework support for most of the common Ruby web frameworks. Unfortunately, Puppet is not considered to be one of them. Although, honestly, a lot of this stuff could be productized in the future, and we could try and get it built in. So what we have to do is tell it how to deal with the URLs. So if you've looked at the network traffic to a Puppet Master, you see there's lots and lots of get calls and post calls, and they say things like /production/ catalog / hostname. And so that gives us a good thing for how we want to break this up. So what I did here in this example is I used set transaction name to take the middle element there and say, well, this is our endpoint. This is what we're going to consider a transaction. And then we'll make the other things into parameters so that we can analyze them later. And that'll give us a breakdown more like this, where we can see that 85% of the time on this server is spent on catalog calls, 7.5% in report, and the rest is miscellaneous. So we already know that the only call worth optimizing here is the catalog call. We could make the report calls, 100% faster, and it's not going to make a big difference in the overall performance. The catalog is where all of the time is being spent. But if we went to then drill into this data, we wouldn't actually see very much. It's just going to say, oh, you're spending all your time, again, in just the overall call, because we have to teach it how to break apart the individual methods within a call. Luckily, the fine people at Puppet Labs have put in the profiler into Puppet. And so we can just ride along on the profiler. So the profiler, if you've looked through the code base, it just puts little blocks around each call, and it says, hey, you're going to profile, here's what we're going to call it. In the newer versions, you set some labels, and then it reports timing information. So we can hook into that framework and figure that the authors have already told us all the most important things to instrument in the code base. This is a horrible hack because this is for Puppet 3.3.1. In the newer versions, you can just add additional profilers. In this version, I had to override the existing profiler, which probably is breaking something, in the actual profiling tools that I apologize for. But you get the general idea. This turned out to be really just instantaneously, powerful. And so as we see by putting in place those profiler hooks, the breakdown changes from this constant dark blue of just call time, and we now see it broken out into the various components. And we can see that the top drivers here are the evaluated AST node and create resources and all of our usual suspects. And the large blue area is just additional data. The other thing that we can do now that it's been instrumented is we can go down and perform transaction traces where we can look at an individual slow call. So if the call for one particular server's catalog is 100 times slower than your average, then you can dive into that one call for that particular server and see what it is that's taking time. When we first put this system in place, what we noticed was that our catalogs were spending all of their time waiting on PuppetDB, which was very surprising to us. So we had to kind of move on to the next phase and instrument the PuppetDB. PuppetDB is just another web application. It turns out it's actually easier to instrument than the Puppet Master because it's based on Jetty, at least the version that I was working with here. Download the Java agent from New Relic. Set that Java args if you're using a Red Hat-based system. Every startup script will be a little bit different. To put that -Java agent, that's the magic invocation. And then again, there's a New Relic YAML file with our basic information. Once we do this, we immediately see a breakdown for the PuppetDB that shows how much time is in the JVM versus how much time is waiting on the actual database, so on Postgres. And then we see that because the Java agent recognizes the web framework here, it can already break apart the transactions into the V3 resources or V2 resources. So we have this basic information. Because it's running in the JVM, we also get JVM information. And this has proven to be a huge win for us. We had a lot of issues where a improperly sized heap was leading to our PuppetDB, just quietly going into garbage collection hell or just crashing. And so by looking at the heap statistics here, we are able to resize the heap for our production and staging environments and prevent a lot of mysterious failures in PuppetDB. The other thing that we get by having the New Relic agents in both the Puppet Master and the PuppetDB is that we can correlate these calls. And so you can actually follow traces as they go from the Puppet Master. If you have a particularly slow trace, it'll go from the Puppet Master into the PuppetDB and into Postgres. And so you can, the more pieces of your infrastructure that you have instrumented, you start to see these patterns. As I said before, when we had a lot of PuppetDB slowness time when we first put the instrumentation in place, it actually turned out to be a missing index inside of Postgres. So we had upgraded the database using perhaps unclean methods. And the result was that we had most of the right data structures, but we didn't have the current indexes. So PuppetDB process was making a lot of unindexed SQL queries, which would then show up in here. And we were able to, by adding just that one index to our Postgres table, we were able to move the catalog time from like 5 minutes down to 15 seconds. It was just a disaster. And it was a huge win for us. So I mentioned previously that we were squirreling away a couple of the attributes, the environment, the host name, or the resource name, and things like that. And the reason why we do that is so that we can put them together later in an analytics system. So this is a picture of the New Relic Insights product. But this is what we use. You may have a different system that you're using. The idea is that by taking our transactions from the agents and they're just automatically put into Insights, all of that data that's available in a time series type of showing can be available as event data. And so we're able to slice this up with a query here. If you're not using New Relic, you can probably get equivalent functionality with some of the other analytics tools that are out there. But the idea being that after the fact now, we can go back in and say, well, show me the performance of the file metadata, but I already know that the plugins system is going to be the like far and away the largest piece of the metadata call. So let's just ignore plugins. So you can ignore things, you can filter, we can look at the data different ways. And this ability to go back and look at our Puppet run data the same way we would our own application data, where we might say, well, which 10 customers are getting the worst experience? What page is driving that bad experience? What's the operational characteristics? We can do the same thing now with our Puppet runs, and that's been a good debugging tool for us. And then, the kind of the classic, the summary, of all operational systems ends up in the log bucket. So Puppet has, already has its own report processor, but we also generate a lot of syslog data. So we found that the data that our engineers were looking for the most often was simply the syslog output from the agents running on the remote side. So by taking our syslog data and putting it through our Heka to Kibana pipeline, now an engineer who's trying to troubleshoot an issue with, hey, why are my runs red? Did this apply? What happened here? Can find it in just one place. It's definitely an operational win for us. And then we were able to add the same Heka system in as a report processor using the Logstash reporter system. So this meant that now we have a single location where we're tracking our application logs, our syslogs, and our Puppet runs all pumped in together. To make this work, we used the Puppet Logstash reporter module, which configures these Logstash formatted reports and an endpoint inside of the Puppet master. Then we had to get them into Heka, which required actually writing some custom code. So this is what the Logstash config looks like. So here in our, our Puppet manifest that manages the master, we just added onto the reports. We said, hey, we need our standard, PE console, the PuppetDB, and Logstash, and we set a hierarchy for that. That ends up being used inside of this Logstash module, and this is then rendered out to a config file, which is read by the module and by the transport. Oops. So that's the kind of the run through on how we did it. We took our existing set of tools. We took the GitHub, the collaborative model, GitHub with the pull requests, so people write in and we have maintainers. We went and we used the same process to send deploys through that we do for our main system. We monitor it using the same APM tools and the same analytics tools that we do for our main applications, and then we put the logs in again. And so, as I said at the beginning, there are two things that I want people to leave here with a different understanding of, and one is this nuts and bolts understanding of how we did it. But the more important one is just this idea that your infrastructure is as much an application as the web apps or backend apps that you are using it to run. And so maybe your tools look totally different than ours, but I bet you can use your same application management tools to manage your infrastructure. You can approach Puppet as if it's an app that you're responsible for, and not as if it's some kind of mysterious black box on the side. And I had a nice chat earlier with the Arista guys who are pitching the same ideas for network gear. I think this is a really powerful pattern that we're going to see more and more in the operations space, is this elimination of areas that were kind of black boxes or mystery, and just turning to each of those and saying, well, if I'm in charge of our Puppet infrastructure and I have to make it run, how do I get guarantees that it's going to run? What are the same things that I would ask of it, that I'm going to ask from an application that I receive from a development team? Then the mandatory, we are hiring slide. I'm sure that this puts us in rare company. So just a reminder that if you're interested, New Relic is a great place to work. I've been working there for 4 years and had a wonderful time. We're looking for site reliability engineers, MySQL people, you name it. And as I said, all of the config files are up on the site. So this has the full config RU with the different segments already spliced into it, and also the custom Lua that we had to write for Heka are both in there. And I'm happy to answer questions now. I have gone far too fast in this talk. But also, if there are things you want to know later, you want to know how we did it or why we did it, definitely feel free to email me. I'm always happy to answer questions or to kind of put some additional data up onto the document. Thank you.
So after PuppetDB Postgres got fixed anyway, what was the worst performing thing after that you see day in, day out?
So originally, we had a lot of problems with PuppetDB from the JVM tuning and from the database tuning. We also had a lot of problems with the older versions of the Puppet Master. The thing in particular that we found was killing us was the time spent building the Nagios resources. And so what we ended up doing is, instead of rendering out the Nagios resources using the built-in provider, we just put the data in using exported types, but we have a standalone process that just reads the PuppetDB and renders out our Nagios configs outside of Puppet itself. You're nodding like everyone has done this, yes.
Were you a developer there so that you were already aware of the tools they were using, or were you just IT and then had to understand?
So the question was I a developer first, or was I just in IT? I am lucky enough to have been both at this company and at many other companies, so we have a pretty closely integrated group. And so I actually worked on the development side of doing the UI and doing agent development work for the New Relic server monitor and in the Ruby agent some before I ended up responsible for the production systems. And so it was an easy transition for me to go back and forth between the two tool sets. But I've found that even, so we think of like network engineers as being, kind of like, it's like the stodgiest of the old stodgy set. And our network engineers have been, just full on into the analytics system and have used the analytics tools that I talked about here to monitor S-flows and to monitor our network architecture, the leaf spine data, and all of these things, and by just taking them and dumping them into the analytics system. And the same now we have deployments via Docker containers, and all that Docker information has also been flowing into the same system. So I think that the tools are a natural fit for people who are in the operations space, and they just need even just a couple days to play around with them generally.
How extensive is the Puppet installation at New Relic?
How extensive?
Extensive. So how many, just out of curiosity, how many masters do you guys have? Is it just one that's managing everything?
Actually, yeah. So in the old PE, 2.6 world or whatever, we had multiple masters and a big set. And frankly, it's like the performance of the newer versions of Puppet is just so much better than the older versions. So we now are back down to a single master for all of our production systems. which talks to a single PuppetDB instance on a single Postgres, all on VMs, and then staging is another set of smaller sized ones, but it's just one stack for all of production and one stack for all of staging. Yes, sir?
How often do you have your nodes check in?
The question is, how often do our nodes check in? So our nodes check in automatically every 30 minutes, which is, we experimented with longer timings when we were having performance issues, but we found that it made convergence too unpredictable. I believe that some of our systems are now on a 5-minute check-in, but I don't actually know. The question is, do we do anything to tune Puppet's performance itself?
Did you do anything besides just changing for example, the heat on PuppetDB index in order to boost performance, like putting a load balancer in front of your masters?
So, yeah, the question is, what other measures have we done to tune performance? So one of the reasons why I actually kind of expanded this presentation beyond just performance tuning is you realize that in the newer versions of Puppet, the performance tuning required for a deployment at our scale is really minimal. So in the older systems, say we had a load balancer for multiple Puppet masters. We've abandoned that, and we now just have a single Puppet master. We do, we've tweaked with the garbage collection on Ruby a little bit, but again, even that is not something that's really necessary in the new system. So there's a lot of measures that we put in place just to get acceptable performance on older versions, and we were able to see through our monitoring and just directly in the catalog runs that when we upgraded, it got so much better that we left a lot of that complexity behind.
If you had a desire of something to be changed inside Puppet to make this kind of thing easier or the performance better, do you have an idea of what that might be?
So from the version that I was working with, the biggest issue that I had was that I had to go in and do a lot of string parsing for the profiler because it didn't have labels. But I know that the new version now has an array of symbolified labels which we could use to turn into metric space. I think that the documentation around profiler usage, I think largely says internal API in a lot of places, and maybe getting that to be a public API would be wonderful. That's the most important thing for me. I guess the second one would be, obviously, editing the config.ru is not a upgradable solution. So whatever changes I put in the config.ru, when we upgrade our Puppet master, get wiped out and have to be reapplied. So there are different ways that you could approach this, but some type of plug-in initialization, I'm not sure if that's possible given the current architecture, or if that's a kind of feature request that needs to be put through.
All right. Okay. Well, you mentioned that you had staging and production. How many systems in your staging and how many systems in your production does your master manage?
So it's a question of, for our staging production stacks, how many servers are we really talking about? So for the production Puppet master, it has, I would say, about 250 servers reporting to it. For staging, it's about 75. All right. Well, thank you, everybody, for your questions.